If you want to start, David, so yours.
Okay, today I'm going to be talking about tools for managing and analyzing SOLPS in OMFIT. The reason why you might want to do this is because OMFIT offers guided setup and run management of SOLPS, explanation of arcane parameter names in a setup GUI, so you don't have to refer to the manual, customizable plots, and it extracts results into arrays that you can use in Python scripts. It also offers tools for doing cross-run comparisons. And if you already have your workflow set up in Bash running SOLPS manually and you're happy with its plots, maybe you don't need this. But if this sounds good, keep listening. Okay, so here's an example of the GUI managing runs. You can see there are buttons for continuing SOLPS run, for checking its status and fetching its output if it's done, for canceling it, or for diagnosing its state. Each one of these has a question mark button next to it, and this opens a tooltip like this one that explains what the button does. I tried to use these pretty thoroughly unless I thought it was obvious what the function did without it.
Mm-hmm.
I did this because as I was learning to use SOLPS from the manual, I was concerned that I would forget how to manage any setting that I didn't write down. And so what I did was I wrote things down in a GUI. And so this SOLPS module in OMFIT is like my notes on how to use the thing. OMFIT's tool for managing SOLPS has a method for diagnosing the status of a SOLPS run. It, of course, can check if your job is still running with a batch manager, but if it stopped and you want to know if it failed or not, and if something weird happens, this thing goes through and checks timestamps of a bunch of files generated by SOLPS, and it comes to a conclusion of what happened. This time it says the run completed successfully, but it could also say it failed or it never started, or it's still active. Here's an example of some hard to understand SOLPS parameters. There's BCENE of 0, and if you use SOLPS for years, you'll know what this means, but if you don't, the GUI will explain to you that this is the boundary condition for energy of electrons on the 0th boundary. And if you go down to this GUI, there's a boundary type.
You can probably use your
Yeah, I'll use this, that's better. There's a BC type, which just is a number in the setup file, but the GUI explains what the number means, and it puts stars next to it, meaning it's a good idea as a default for this type of boundary. And then it has values, 1 to 3 values for each one. And the GUI has translated what 08 means, and it tells you what you're setting as you set the value. If you were just looking at the name list, you'd see an 08 and a 500E3 with nothing else, and the BCENE. So the GUI has explained things like that, and then it has corresponding translations for the particles and ion energy.
Right. I think boundaries. People who have run SOLPS before probably appreciate the value of something like this, because the SOLPS input file is quite hard to understand, right? There is a big manual that you went through, and as you said, you built this as you were learning about SOLPS, right? And
the manual is so mature that some parts of it override earlier sections. It'll say that the chapter 4 will say the information in chapter 2 is obsolete and it's overridden by this, for example. That may have happened only once, but once is enough to make me scared, right?
And that's also happened in input files as well. Some input files
right? Yeah.
Are actually overwritten by other files. So sometimes you don't need to change everything, but that's very dangerous situation where you think if you forget to change the right one, you are doing a wrong change. But that's also happened, like the B2 main is actually the one where you should always do the change, and then some other other files are just overwritten by what you're writing in there.
Right.
As an example.
And so in this setup GUI, I've tried to put in warnings for those types of gotchas so that you won't get tripped up by that sort of thing.
And I'm sure we'll go through this probably when we open the module itself. But SOLPS, just to remind, it's a collection code
It's a
itself.
huge, big thing. It's a very old project. It's been going on for a long time.
But which is
and
also,
it's hard to keep something.
It's also the collection of more codes, right? So you have input files
They're all interacting with each other.
Codes.
So it's pretty natural that this kind of conflict we're discussing could happen. It would be very difficult to keep this straight, but I've tried to make a tool that helps remind you, hey, this thing you're setting is going to get overwritten if you set this other thing. So there are warnings in this GUI to try to describe that. Okay, another feature I discussed is that this module can produce plots which are customizable. You may have seen a B2 plot output that comes on a fixed color table, and you can do things. The command line lets you set ranges and stuff. It's really a very good tool, but this is even better. It uses matplotlib. It's pretty. You can change color tables. You can zoom it differently. You can zoom B2 plot. And anyway, it's also an array. So you can take this output that's on this grid as an array and put it into some custom function you think up for whatever reason. You can subtract or divide it by your experimental result, etc. It will quickly gather a lot of basic quantities right out of B2F state, so it's very fast. But it also supports running an arbitrary expression you can pass to B2 plot, and then it actually calls B2 plot and then steals output from that and turns it into an array. And then when that happens, this is what you get. So here's a B2F state file in the OMFIT tree, and it's been parsed to tell you its dimensions, and then it has some parameters. NE and TE are the electron density and temperature, of course. Then it goes on. There are many more than these. This OMFIT SOLPS class can be used to parse several different SOLPS input files, and you should be able to load it outside of the OMFIT GUI. So if you have a SOLPS input-output deck and you just want to translate it into Python, this class should let you do that without ever starting OMFIT. Mm-hmm. And if it doesn't, it's a bug, and we'll fix it. And so it makes it easy to access results and put them in your scripts. There are also tools for doing cross-run comparisons. Here's an example where I just changed the boundary conditions on 9 runs. I just doubled the power, cut the power in half, and then increased the density and reduced the density, and then kept the center point. So that's 3 by 3. So this is 9 runs, and and then I ran them for a few time steps. I didn't converge them all the way, but I mean, you can see that doesn't really look converged, does it? I just ran it long enough to differentiate them so I could make this plot. And then here's the density temperature plot. The other one was density. And then you can look at the parameter space that they make. You can see those little markers. So we have NE on the core, which is a boundary condition that I modified. And then the core heat flux, which I modified. Those are inputs. And we have an output, which is the lower outer diverter heat flux. And again, it's not converged, but you can see there's a trend that's emerged. And you can see where the runs are in this space. And you can see it's marked them as not converged. So some details are I set this up with SOLPS 5.0 in mind, although it probably works with 5.1 because a lot of the inputs are very similar. I have some development planned to work with SOLPS Eater. And the file handling.
Is it clear what is different in SOLPS between SOLPS 5.1 and Eater?
Maybe. I haven't gotten that far yet.
Okay.
This does work for SOLPS 5.0. I bet you it works with 5.1. SOLPS Eater is coming soon.
So one thing with the SOLPS Eater is I think that they designed it so that it can also write the results to IMAS.
Yes.
So if we have that set up, we could actually read the outputs from IMAS directly.
That would mean that a lot of the output handling that I've done here wouldn't be necessary, and we could do a different, much smaller script for SOLPS Eater.
As an update, we are actually going to migrate to SOLPS Eater very soon, probably in the next 2 or 3 months. We want to do this before Xavier is coming.
Okay.
So that we can, show him something or say, hey.
Yeah, or bring up issues or yeah.
So, I mean, just saying we are going to do this step probably just after the APS, I think, but it's really coming soon. So maybe we could work in parallel with that.
Yeah. And if you
I mean, I think it's a learning process, right? As you guys are doing it, right? I guess I should involve David
And
because now we are all working with SOLPS 5.1, right? So the difference between 5.0 and 5.1 is that in 5.1 we have the we have triangle, which creates the triangular meshes for the neutros. That's the main difference. But then SOLPS either is all another story.
I think for what the OMFIT module, SOLPS OMFIT module, matters. It's really the inputs and outputs. So if the inputs and outputs remain similar, at least
the class will still be useful for parsing them.
Correct. If the switches have the same names and so on, then
And just
we'll have to be careful.
No, yeah, but
verification. So that it will still be, we create the meshes in DG and Carré, and then whenever we have all of that set up, then one is connected to the OMFIT, right? You still have to do this part.
OMFIT doesn't replace DG or anything, although it would be nice if it had a button for opening it so you could build your own input deck. Right now it's working off of a template input deck. That's a starting point that you can then modify, which is kind of a limitation. But once you set up your first input deck, and then if you want to expand around it by doing these modifications, then it would be useful. Okay, and then I'll just mention file handling quickly. OMFIT likes to store temporary working copies of its files within itself, and it deploys them to Scratch to run, and then this thing can also read your existing runs. Like if you have one, you can use it as a starting point. So in summary, OMFIT can help with setting up your boundary conditions in SOLPS and adjusting them. It can help with run management and tracking, post-processing and plotting, and cross-run comparisons. And then I'm going to do a demo, and I wrote down the steps in case you would like to recreate it later. Okay, let's go to Iris, starting from 0 here, right? Oh. It's more exciting this way because it might fail. Wait, did I check out first? Yeah, it's empty.
And he's also working the things we were looking at together some time ago, where we wanted just to import the output in OMFIT. So already some SOLPS runs that we're already ready.
Sorry, what?
You remember when we
Yes, it can import output.
You can also do that. Okay, gotcha.
You have nothing to write folder. Too fast.
It'll catch up eventually.
Okay.
Do you know why it's so slow? Do you have too many branches I haven't pruned?
On Iris,
Git
it's slow?
Yeah.
Well, probably it's just the file system on the network file system. So everybody here is a SOLPS user? Yeah? No? Do you have a new user?
No, I am interested in reading SOLPS results that other people have done, and then post-processing them and doing things with them.
Oh, I see.
As opposed
Okay.
to actually running them.
This will help you perfectly.
This will help me perfectly.
So, yes, I helped someone today.
Good.
Okay. Should have checked out the branch first. It feels slow. It is slow. You don't launch this in Unstable, do you?
What do you mean? No, I mean, we do all this all the time. I just wonder why it feels slow.
It is slow. It's faster on my laptop, but most users are more likely to run on the server cluster, so I'm doing it that way for that reason.
Yeah. Makes sense.
So I guess this is a file system waiting to build this sketch. There it goes.
Yeah.
Okay. So if you missed that, I just told it to import the SOLPS module. Okay, now I'm going to double click it to open its default GUI. And then I'm going to tell it to load inputs.
Can you also show us what's
Yes.
the tree like?
Yes, let's look at the tree. What it's doing, when I told it to load inputs, it got those from a run that had already been set up. So it's using that like a template. So what it did, it also loaded the outputs because that box was checked. I guess I went too fast.
Yeah.
Should I clear it and redo it?
No, it's okay.
Okay. Okay, so its inputs are divided into a main and a base run, which is how SOLPS runs are all often set up. So it has these main input files. This is the boundary parameters name list, for example. Then it has several others. Then it has these other B2AH, B2AI, etc. And the outputs have B2F state, B2 time. So it's loaded all those from an existing run, which we can start from and then start to modify.
Well, so one thing that you went too fast over is which default run did it pick?
Oh, sorry. Should I back up?
That's not clear.
There was, yeah, that's true. I'll just start over. Okay, so here you can choose a run. You can choose your starting point. There's a directory browser, so you can go and pick one. So I've picked this one here, which is one on Iris. But if you have your own, you can type in the path there.
So this is, for example,
OK.
What what's your name?
Camera.
What camera would do, right? You point to the directory that someone ran their SOLPS run.
Yes. And then you'd also want to have this output files as well box checked. Then you can load it.
Okay, so now it's more clear.
Yeah.
Yeah, good.
After waiting for OMFIT to start for so long, I got impatient. Okay, so now it's made local working copies of all the files. So it's not going to touch the run on disk that you pointed it to. It's not going to mess up someone's work if you base on it. It's just going to work with its own temporary copies that it now has, which will be saved with the OMFIT project if you save. Okay, so let's get started. I'm going to follow my script so you can reproduce what I do. Okay, we loaded inputs. Now I'm going to modify the boundary conditions. So here's this is a double null case that I loaded, so it has 12 boundaries. There are 2 boundaries on the core for the outside and the inside. The inner core boundary, we're going to change the particle condition from 2 to 3, actually. And then we'll change this particle boundary condition. So we're increasing the density of the run, and we're going to increase the heat flux coming out of the outer core side. Okay, so we've modified the boundary conditions from the initial case. And now we're going to run for 5 steps. So I'm going to tell it, there's 5 steps right there. That's not very long. Usually you do like 1,000, but we don't have all day. So I'll tell it to continue. And right now it's deploying a run to disk, and you can see it knows its status is launched. If you tell it to check on your run, it will do a check. It will see that a job is active with status R right there, and it updates it to tell you that the run is currently active.
So what this has done is it took both the main and the base run, right?
Mm-hmm.
Created the right directory structure with those input files,
mm-hmm.
and then went on, I guess, Iris, or yeah, in this case, Iris.
But you could also deploy to Saturn.
To Saturn or other machines. I guess we should set it up for different machines. NERSC, yeah. And then submitted the job for the SOLPS run. So SOLPS is a serial code, right? At least the version 5.0, it's
yes.
serial, right? So it's just one processor that you allocate for usually a long time.
Yes.
Right? Usually you put it into the long queue or something.
Right. Like at least, I mean, I don't know, usually 72 hours to start with.
Well, when I ask it for 5 steps, it's going to put it in the short queue.
Oh, okay. So one thing that the module is smart about is depending on the number of steps that you request, it kind of has a feeling for what queue to use.
It estimates the amount of time you need with some padding based on how many steps you ask for, how many boundaries there are, and if you're doing coupled or not. I think those are the things it considers. It makes up an estimated runtime, then it finds the shortest queue that's allowable.
which is pretty smart.
And in this case, it submits it to short, medium, long, and then the job manager decides which one will start the job faster.
Okay.
And if it were longer, it would do just medium, long, or just long. Okay, it's probably done by now. Let's see. Yes, it's finished, so it's gathering it. And now this status here is gathered. This could also say failed if it failed, but it didn't, which is good. So now that that's done, we're going to open the plot commands, which are here. And I'm going to close the main GUI so that the GUI refreshes are faster. So the first thing I'll check is this run progress and convergence summary. This shows some interesting quantities versus time. This, unlike normal SOLPS, this thing is keeping copies of old v2time.nc files. Usually when SOLPS restarts, it throws away its history and starts a new one because no one cares, but I thought it was kind of interesting to see it converge from 0, so I decided to keep the other ones around. And it can throw them away and compress them if you don't want that. But what you see here is the run started and then it somehow got a second copy of itself, which happens sometimes. Anyway, so here's the density at the outboard diverter following with time. And if you ran longer, you would see it continue to evolve. This is a useful plot for seeing if you're done or not. You can also, there are also other ones in here, like this resol.d. This plots some residuals versus time. And if you're used to looking at SOLPS output, these can help you understand what's going on and if the run is converged. Okay, then let's look at our 2D plot. Here, this is very flat because we ran for 5 steps. We initialized to a constant temperature and density, and then started running. So it started to evolve at the boundaries. The core boundary is getting more dense, the diverter has a sink. So something happened, but not very much in 5 time steps, or 10 because it got the others cut in there. We can change this instead to TE, or we could have used this drop down to pick a quantity. And then we can make a plot of a different parameter. And there's TE. These are also available out of the B2F state file if you want them as arrays. They're all in here.
So, and I guess for these NE and T data that is in the BF2 state, it's probably, it needs to be mapped with some logic to the proper grid.
Yes.
Right, and that logic, I would assume, if anything, it's probably in the plotting routines that you wrote.
Yes, it is. But it's reading the mesh file, which is what? There's part of the mesh information, but it's mostly. Well, yes, there's a mesh.
Yeah, the geometry.
Yeah, I think that's it. Anyway, so yeah, it reads a mesh and it reads this, and then it figures out how to make the properly mapped 2D plot. And there are a bunch of options in here you can explore, but you can show the mesh like that. If you actually want the mesh drawn, you can see it there. Draws all the cells.
Pretty nice.
That was kind of hard to make it connect them all well at the boundaries. There are a lot of seams in there. Okay, what's next on the agenda? Yeah, this is another fun thing. What I did when I was trying to do a project with this is I loaded the module about 100 times to do different cases and variations. And I used these tags up here to keep track of which one is which. But you can go farther than that. You can apply these labels. You can tell it, does the thing appear to be stable? Has it converged yet? Is it detached? Well, this one's incomplete, I don't know. Is it reasonable looking? Well, it's incomplete. And then you can flag it and say, I inspected this one. And now when you look in the tree, it says it's inspected. Then you can keep track of, okay, I ran these finished, I checked these, and then you can go and you can launch it again.
Right. So I think SOLPS, we said it's a serial, at least in version 5, right? So and you have to wait for days for your solution.
But you can launch like 10 runs at
Right.
once.
So
or
my
more.
question was, could you use this tool to submit many jobs, let them run, and somehow wait, a couple of days, and then gather the status and compare them and so on?
Yes. Well, the solution I have of loading the module several times is a little clunky. I should have had one module keep track of many cases, which is a change I'm planning to implement. But as is, at least these modules can find each other in the tree, link together, and then give you scripts to say, check all of them. Check the status of everything that was running last time.
So the way you would do this is to, let's say that we wanted to run, and we submitted a run instead of 5 steps. Let's say it's 1,000 steps, right?
Yeah.
So now, let's say that we want to run another case. What would you do? You would import another SOLPS module.
Or duplicate this one and modify it.
So
usually you want to do a family. So you set one up,
Uh-huh.
then you just say, okay, I'm set up. Now let's just make another one. And then SOLPS 2. I would give these more descriptive names like higher density or this boundary adjusted or something. And now there's another one here.
Which then you can modify and submit the run and then keep going. And then I guess there is a lot of value in those status messages that you have.
Yes. Okay. It was horrible trying to figure out what's happening without them. So here I'll reduce the density and run SOLPS 2 with a lower density. And while that's going, we can go back to the first one and run it again. And this is putting them all in their own separate workspaces, so they're not going to collide with each other.